All right. Now it's everything is sorted. Yes, I'm happy you can all still see my screen. Now I can continue. So here's what I was saying. I was saying, what we look at, what I always want to explain, I want to make sure you are hearing me. I don't want to speak in high, talking to myself and all this, because I want to answer the questions that you have, as I'm teaching all of you, to make sure you understand what is going on. Sir, what are you saying? I've said, listen, I am not trying to make you know the whole maths today. That's not the job. That's not my job. That's not my intention, rather. I'm not trying to make you know the whole of maths today. So I know that it's not going to be the whole of maths. I want you to know one thing. So I want you to listen closely and make sure at the end of the lesson you know that one thing or two things that I'm going to be explaining to you. Are we together? Can you all hear me when I say that? How many things should you know by the end of the lesson? Can you all hear me? Antonisha? Can you hear me? Yes, okay, Uratele. Yes, how many things do I want you to know by the end of the lesson? Do I want you to know the whole maths? Hello? By the end of this lesson, do I want you to know every single thing? No, two things only, right? Yes. So those two things that I want you to know, those are the ones I'm trying to show you where I'm taking them from, so that you understand. I said algebra and graphs has expansion, factorization, solving equations. For those who want to see factorization, you can go on my Facebook page. You search on Facebook, Mr. Clarify or whatever. I'll send you the link, and you see the another lesson I did explaining factorization, a lot of the things, so that you can catch up on it. And then equation solving. What I want to start with is inequalities, solving their graphs, because it's a question that comes a lot of. You need most. Are we together, students? I'm going to make you know everything, but I'm starting with the things that you need most. Okay? So these things today, we are doing inequalities, their graphs, and we're going to do bounds. So write with me to say graphs of inequalities. Write to me to say graphs of inequalities. Write with me to say graphs of inequalities. Write with me to say graphs of inequalities. Now I'm going to open a question, and we're going to be learning from questions, past paper questions. And I'm going to explain to you the main things that you must do, and you see, I'm sure you'll be able to understand. So let me open them. Okay, wait. Give me 1 second. I'm opening all the questions I want to do. I don't know why they hadn't opened. Sorry. Give me 1 second. Okay, I've opened the questions. We're gonna go through about 3 or 4. Then I go to bounds. We go through about 3 or 4, and then you'll be done for the day. I'll be happy. Then I can give you questions to practice. All your maths marks will be released tomorrow. Okay, it's taken a bit of time, but I'm done. Now you'll be able to see my screen. Give me 1 minute to share. Okay. Tell me when you can see my screen. You can't see it? Wait. Okay. Okay. Now you should be able to see my screen. Are you able to see it? Right. Okay. Can you see? All right. Great. Now, I'm sure all of you can see my screen. Let me just make sure that I stretch it out. All right, so now we're getting started, and this is going to be the very first question. I want to explain some things that you're going to use. Remember, the most important thing is never break a rule. Um, One sec. All right, the most important thing is that when I give you a rule about how we're going to solve it, just apply those rules, just do those steps, and then you're going to be fine. So I'm going to be moving a little bit fast because we lost some time. I need to make sure we regain this lost time. So sorry for that, eh? Now what I want to do is I'm going to move a little bit fast. I'm going to move a little bit fast, and we'll see how it goes. So the very first thing we're going to look at is this question, which says, write down all the inequalities that define the region R. So let me just say something here that is going to be very important about how inequalities are so simple. But there's just one thing that all of you must always remember. Can you all hear me? And can you all see the screen? Okay, good. There's just one thing that everybody must remember when you are doing inequalities is this. You'd never sketch an inequality. There is nothing called sketching an inequality. What you do is you sketch a line, an equation. Every line has an equation. So listen, you don't sketch inequalities. You sketch equations. Are we together? You will never ever sketch an inequality. An inequality will then be the region after we have sketched an equation. So all we are going to then do, we will look at the inequality to know when we are sketching, when we are shading, or when we are choosing a region, are we taking above the line or are we taking below the line? That's the only thing the inequality will then tell us. Don't go to an inequality to know which line to put. That is the biggest mistake that people do that will make this seem hard. Is you look at an inequality and you say, oh, how do I sketch it? Hey, what are you saying? You don't sketch an inequality. You sketch an equation. Then you are going to use an inequality to choose a region. So let's try it, and make people see what I'm trying to talk about. So the very first thing we do here, they're saying write all inequalities that define the region. I don't know if I want to start with this one or I want to start with the one which says sketch. Let me go and start with the one which says sketch. Then I'm going to do this one which says write all inequalities that I'm going to start with one which says sketch. Look at this one. Let's start with this question which I'm going to open here about sketching. Here it says, look at this. This is the first question we'll look at today. Remember what we are going to do afterwards. Here we are starting with this idea. Let's see. So let's start with this. We're doing graphs of inequalities and then we'll do bounds. So listen, by shading unwanted regions. Okay, we know that inequalities will be now the region. But listen to this, my important people. We cannot get to a region before we have the line. Lines are going to choose regions. How do we make lines? We don't see this as an inequality. We will see this as an equation. So whenever there is an inequality, first deal with the equal sign so that you have the line. After you have the line, then you use the inequality for the region. Listen, you are not letting me down. Students, one thing I don't want is people who don't put the rules in their head. Put this rule in your head. Listen. Listen. Forget about everything right now. Focus on what we are doing right now. I want 100% in the work I'm giving you. So listen to the steps, please. Listen to what I'm saying. The first thing you do, are you listening? The first thing you do is you do the line. And a line is not an inequality. A line is an equation. So I don't want to see an inequality sign in step 1. We will have a major problem if you do that. You and I are going to have the biggest problem ever. If you see an inequality and you try to sketch it, I'm going to have a big problem with you, my friend, because you're not obeying the steps. We're going to have a big problem. So, sir, what do you mean? What is the first thing I must do? The first thing I expect each and every one of you to do is, can you put equal signs, please? Oh, my days. I'm sorry. Again? Come on now. What is going on? Okay, let me open. The first thing that I want from all of you is, listen, can you put an equal sign, please? Then when you have an equal sign, can you now shade the region using the inequality? Don't start with the inequality. Inequality is not going to be sketched. It's going to be the region that you're going to choose after you do with the equation. I know all of you can hear me. Wow, I just affected it again. Let me do it like this so that I don't affect this connection. It's a very fragile connection, apparently. All right, so let's do it. Sir, this is a simple thing. You said we do the equation, then we'll look at the inequality. Thank you. I'm proud of all of you. That's what I said. So if you look here, let's do the equation. Step number 1. Everybody, don't you change these steps. Step number 1, let's do the equation. X equal to 2, y equal to x plus 3. Do you see the 3 equations? Students, do you see them? Right. Let's do the equations. Let's sketch. These are the easiest things ever to sketch. So these are the things we're going to sketch. Let us sketch them. Let's sketch the 3 equations, please. The first one says y equal to 3. We go on the y-axis, we go on 3, we put a line. The second one says, okay, let me tell you now the type of line you put. When you are now putting a line, just check for me this inequality inside. If it has an or equal to below, then you're going to put a line which is solid. If it doesn't, like here it doesn't, then put a line which is dashed when you are sketching. Okay? Are we together? Good. All right, let me repeat it. I love it. I said, listen to this. Give me 1 sec. The first thing you're going to do, Antonisha, you're doing 2 things. Let's say we've gotten the question. I'm restarting. I'm going to erase everything. You are scrolling down through your paper. Bing! You get to this one. And what is the question saying? Wait, let me change. Give me a second. Let me change this. It's not sustainable. CXY, change to this, more stable. Okay, thank you for your patience. So listen, we've gotten to this question, right? Everybody, are you seeing my screen? Can you all see my screen? Can you all see my screen? You can't. All right. Let me fix it and we do a strong lesson. All right, I've fixed the connection so there's going to be no more problems. Thank you. Right, everybody look and pay attention. Let's go through this together. So let's say you meet this question. Let's just do the steps and I'm going to do several questions and you'll be fine. So what are we doing? We are graphing inequalities. If somebody asks you, what were you learning today? I was learning how to graph an inequality in a way that I will never ever get it wrong. So that is, we were mastering inequalities. Were you mastering inequality? Yes, I was. Are you sure? I'm 100% sure. What is the first step you do when you get to an inequality? Can you do me a favor? Don't you dare try to sketch these inequalities. You're wasting our time and your time, which you don't have. The first thing I want you to do, just go below every single thing, change the inequality sign to an equal sign so that you can sketch the lines first. Then we will come back here. Don't worry, we are coming back. So let's do it. We're going to sketch the lines first. This is going to be y equal to 3. This is going to be x equal to 2. This is going to be y equal to x plus 3. So these are lines that we will sketch first. And then after sketching the lines, that's when we'll come back to the inequalities. So let's go sketch y equal to 3. Now, when you are sketching, just look at what the inequality was like when you're sketching. If the inequality had no equal to below, then you're going to put dead dots. But if the inequality had an or equal to like here, then you put a nice solid line. So there are two things you look at. There are two things you look at. When you are sketching inequalities, this is the first step. You convert everything to an equation. But when then you go and you sketch those lines. These three lines, line 1, line 2, line 3. If you don't sketch them, you are not going anywhere. You are wasting my time and you are wasting your time. So you better do this, man. Are you hearing me? Don't waste our time, class. The first thing you're going to do is you are going to make the equations. Then you are going to sketch the lines. So do that. Then when you sketch the lines, some of them are dotted, some of them are solid. The dotted lines, you see them by seeing this inequality sign, which has no or equal to. So I'm going to go and sketch the y equal to 3, but it will be dotted because its inequality had no or equal to. So I'm going to make it dotted. So I go to y equal to 3 and I make it dotted like this. I'm going to y equal to 3 and I make it dotted. Then I go to x equal to 2, which means on the x-axis, I go where x is 2. Then since this has on or equal to, listen, you are doing x equal to 2. But its inequality had an or equal to, so you make it a solid line. So you're going to go to x equal to 2 and you make a nice solid line like this. Then you do the last one. Y is equal to x plus 3. You need to know how to sketch these type of graphs now. You need to know how to sketch them. This is y. The graph is actually y equal to x. This last one is not part of the graph. It's just where you cut the y-axis. So we are going to cut the y-axis at position 3. So we go to the y-axis at position 3. This is where we are cutting it. But which graph are we doing? We are doing the graph of y equal to x. What is the graph of y equal to x? When you go up, it is a graph which just joins corners like this. For those who don't know, it joins corners. If it was y equal to negative x, it joins corners going down. Y equal to x, it joins corners going up. So we are going to join corners like this. Corner, 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 like this. This is the graph of y equal to x plus 3. This is the line y equal to 3. This is the line x equal to 2. If you do this, you are showing elite level knowledge. You are showing that you know how to sketch an inequality. An inequality is not a line, it's a region. But for you to do that region, you need the lines first. So you need to be working with the equations first. Then when you have the equations, now you can shade the regions. So now we're going to shade the region. But here, look, do they want the wanted or unwanted? They want the unwanted region. So here you have y less than. Listen, if it's less than, that means it's below the line. If it's greater than, that means it's above. So here, if it's x less than, that means it's going to be to the left of the line. Here, if it's y less than, that means it's going to be below the line. So these are the wanted regions because they are the ones being talked about by this. Y should be less than 3. It means you must go below if y is less than. If x is less than, that means you must go to the left. If y is less than, that means you go below. So this is one more thing that you are knowing. We are now doing regions. So listen to this. Listen to this. I am making you know what the inequality is saying when it says, you now have the line, right? You have the line y equal to 3. What does the inequality y less than 3 mean? It means below. When y is less than, that means they want below. If y is greater than, that means they want above. So here y is less than, so they want below. If x is less than, that means they want to the left of the line. If x is greater than, that means they want to the right of the line, where they want. So listen, x less than, I said it's to the left. Are you hearing me? When you are choosing regions, don't let me down, hey? You are not allowed to let me down. I'll be extremely disappointed because I have said this. I said put the lines, and you are going to put the lines. Then I said find out the regions which are wanted. And when you are dealing with y, it's either above or below. But when you are dealing with x, it's either to the left or to the right. If x is less than in your inequality, they want to the left. If y is less than, they want below. Are we together? Are you hearing me on how you choose regions? Did you hear me? Students, I said when you are choosing regions and y is less than, they want below. Now, they want you to then shade the unwanted. The inequality does not tell you the unwanted. Why would it? The inequality tells you the wanted. So now you go with your red pen after writing the wanted, because you have looked at the inequality. Now tell us the unwanted. The unwanted is above this line. So the line y equal to 3. That's the unwanted. Then the other one unwanted is to the right of this. That's the other unwanted. Then the other one unwanted is above this other line. So let's see what it is. Let's see which unwanted region to shade here. We are going to shade, if we're taking a pencil, we are shading to the right, which is here, to the right of this line, because that's the unwanted region to the right. So we are shading this section here, and it should be above y equal to 3, so it should be here, and it should be also above y equal to x plus 3, which is here, so it should be above it. So above this y equal to 3 is everything here, then above this slanted one is now and to the right, which is here, so the region which is unwanted is this one. This is the unwanted region which you must shade. Have you seen? Don't try to run to the answer. You are not going to get there. You're not going to get to the answer by running. You are going to get there step by step. So don't try to run. I went to here. I wrote the wanted regions because you understand inequalities. If y is less than, the wanted region is below. If x is less than, the wanted region is to the left. If y is less than, the wanted region is below. But they want you to shade the unwanted. So now tell us the unwanted, because you know the wanted one. Tell us the unwanted. Above, right, above. So you go to the right, which is here. It should never be to the left of this line, so it will stay to the right. Then it should be above this one. Then it should be also above this one, so it's going to be only here. This is the region, and you are done. Any questions? Oh, really? My screen is coming and going. Ooh. Okay. Let me do it as a different one. I have several questions. Let me go to this one. Are we seeing? Right. The region what? Then they'll say shade. Don't you hey, listen. Don't even look at that. First thing first. Look, change all these things to lines. Right. Sir, what happens when I have something like this? You have two lines. Because we had the -3 less than y. Let's open up this. This one means, if we open it up, it means we have two inequalities. -3 is less than y. And we have y is less than or equal to 2. These are the two inequalities. Now, we are going to first make them lines. So take your pencil, make them lines, and sketch those lines. So we have a line here called y equal to -3. We have a line here called y equal to 2. We have a line here called y equal to x minus 1. So these three lines are going to be drawn. These are lines. Before we even look at the inequalities, we need these lines. Let's go. Y equal to -3. I want you to look, when you are sketching, I said you should then look at the inequality. If the inequality has no or equal to, that means you put a dotted line. Like this one has no or equal to, so we put a dotted line on y equal to -3. So we go to -3, we put a dotted line like this. Are we together? Then we also go to y equal to 2. Don't change the steps. Then go to y equal to 2. You go to y equal to 2. Here, since this one had an o equal to, put a solid line. Because there is an o equal to on the inequality. You are sketching y equal to 2, but you just confirm its inequality before you sketch. Its inequality had an equal to, so it is going to be a solid line when you are sketching. like this. So we have put these. Well done. Now we are left with this one. Don't let me down, please, as a class. I'm begging you. When you're sketching this one, you're sketching the graph y equal to x, which means it goes corner to corner, corner to corner, going up. That's the graph y equal to x. It goes going up like this, corner to corner to corner to corner, going up. But what you must know is it should pass through minus 1. This is the y-intercept. The graph is this one. This is the y-intercept. So we go to minus 1. It should pass through there, going corner to corner to corner to corner. So we start here. We make it go corner to 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 corner, going up like that. Okay? Until it gets to this corner here. So this is what you do. Now, do you have the lines? Yes. You can remove now, since you have the lines. Now you are going to now choose the region which they want. Here they want it to be what? I told you, when you're dealing with y, it's either above or below. So they want it to be above this, because y is bigger than -3. But y is less than 2, so they want it to be below this one. So in other words, if you have -3 less than y, that means y is bigger than this, so they want it to be above. Then you have y less than or equal to 2. This is going to be below. Do you understand? These are the regions. Here they want y less than, so they want you to go below this. If it's y less than, you are going below it. There are two things involved. Listen, there are two places that you can make a mistake. Number one is by sketching the lines. So if you still have a problem with sketching the lines, this is what you need to practice: how to sketch lines. If you are good at sketching lines, but you are bad at now the second stage, which is now to choose the regions. So I'm making sure you know that there are two things involved here. We have sketching, which we have sketched beautifully. This is an amazing sketch. These are solid lines here. Why is it solid? Because, and when you do a line, by the way, you must label it. So this is the line. Label your lines, okay? Be proud of your lines. Label your line. This is the line, y equal to x minus y. This is the other one, and top here is the line y less than or equal to 2. But here we are doing the line, so it's y equal to 2. Then this is y equal to -3. Now here they said it must be greater than -3, which means y must be greater. So that means they want above. When y is greater, they want above. When x is greater, they want to the right. The wanted. When y is less than, we are now choosing the regions. When y is less than, they want below as the wanted. Here we have y less than or equal to x minus 1. They want below as well. Now, but here, what did they say you must shade? They said shade unwanted regions. Shade unwanted regions. So let's shade the unwanted. This would be above this, below this, and above this line. These are the unwanted regions. So let's go above this slanted line, y equal to, okay? Above this, and we also should go above, we should also go above y equal to 2. Let's go above y equal to 2, and we should shade this region above y equal to 2, and it should also be above this line, because they said we should also be above this line. So this is the region which you have shaded, which is above this, and it is also above this y equal to 2. Then below y equal to -3. Can you all hear me? Okay. Okay, good. So if I'm going to shade the region, they said below this y equal to -3. This is the region below it, y equal to -3. We have, it should be above, hello? It should also be above this line, the slanted one, this line, the slanted one. The region above the slanted one, you can all see it, it even keeps going like this. The region above this, the region above this. So what would you remain with? This is where a lot of people struggle. Let me just re-emphasize with these lines. Give me a second to erase and explain something which is deadly. If I go to this question here, let me go to a question here. Right. Is it this one? No. I'll do this one. Let me start with this one, which is lines. If I go to this section, they say, write down all the inequalities that define the region R. How do we get to the region R? You go step by step. I have lines which I must first identify. This line is y value of 4. So this is the line y equal to 4. This line is y value 3. So this is the line y equal to 3. This line is x 2.5 on x. So this is x equal to 2.5. Then this one, you can see that when y is 1, when x is 1, y is 2. So that means one value of for x, 2 values for y. So you can write it like this. Y is equal to 2 times x. Right. And since it passes through 0, we are going to write to say here, y is equal to 2x. If you want to calculate it, another way to do it is you can find the gradient of this line. But let's just get it out there to say if x goes up 1, then y goes up 2. This graph is called y equal to 2x. Now we have these equations. Now we are picking regions. Let's just pick regions. This R is going to be above this. But I want you to see that this has a dotted line. So when we are doing, we're going to say y is greater than 3. So that we put a dotted line. We want to be above it, but we want to have it be dotted. We want to have it be dotted. To be on the left side of that line x. So we say now x is less than or equal. So if we now go to a way that you would have seen this region which is wanted is you could have done it like to put all the unwanted regions, then you remain with one region which will be always wanted. So if I come here, they said shade all the unwanted regions, the regions that are unwanted. So you go above this slanted line, you shade its entirety. We don't want anything that is above this line. So shade, 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 shade. All this region, shade it, class. Above this line, we shade it. When we are shading unwanted region, we can go line by line, shading the whole section. That is that. So we have shaded the whole section, which is above, like this has said, which is above this line. Then another region which we want to shade is above, is above y equal to -3. So you go to the whole region which is below that. All this is below y equal to 2. So you shade it. Then at the end of the day, you remain differently for everything to show that you know. That's going to be the next thing which we will talk about now. How to shade differently. But let me try to do it using one last question and see if I'm gonna get you somewhere. Yes. Oh, you're going to be left with one region which is not shaded. Let's do this one and let's see this hard one and let's see if we are going to get it correct. Are you all? Okay, can you all see, students? Antonisha? Let's do this one and let's see. Don't break the rules, please. You get it correct. You get it correct. Are you all watching? Good. Karabo, are you watching? Karabo. Okay. Shalom, are you watching? Hello? Antonisha, can you see my screen nicely? All right, good. So let's do it this way. Let's do the steps here. This is like the last one. So make sure you're watching with me so we can do it. Can you all tell me what is the first step to doing an inequality, please? Yes, you change the sign of everything to an equal sign. So I want to see you say x is equal to 180, y is equal to 90. Then here we have x plus y equal to 240. We need to take x to the other side, okay? We'll still have, first you can write it as x plus y is equal to 240, which will eventually become y is equal to negative x, because this x is a positive, goes to the other side, it becomes a negative, then plus 240. Okay, 240 is still there. Then what about here? This one you become 2x plus 3y is equal to 450, which you take x to the other side, you get 3y is equal to negative 2x plus 450, which you now take 3 to the other side, you can have it to say y is equal to negative 2 over 3x plus, what's 450 divided by 3? That's 150, okay? Because 3 will go and divide everything, so you can say plus 450 over 3, which becomes y is equal to negative 2 over 3x. Then you say plus 150. So the lines which we have to sketch, which we must be able to sketch, are these ones. These are the lines that we must be able to sketch. Are you seeing my screen? Let's sketch the line. X equal to 180. We go where x is 180. This is 150. This is 175 because it's between 150 and 200. So it'll be 150, 160, 170, 175, 180. So 180 is here. This is 180. Which they said x equal to 180. So we're going to go up with this all the way to the end. Good. Then we now want y equal to 90. We go where y is 90. This is 50. This is going to be 75. And that's 80. That's 85. That's 90. So 90 is here. Which we are going to go all the way with this 90. Now we have y equal to 90. And we have x equal to 180. You should write that down. Now we have another one, which is y equal to negative x. Class, don't let me down. The graph is this one, y equal to negative x. This is just where it cuts the y-axis. So you go to 240, okay, which is here, because this is 200 and this will be 225. Yes, I see a hand is up. You can ask. Okay, well done, well done, well done, well done. When we are now sketching, well done, well done. The question was, isn't this supposed to be dotted because the inequality has no or equal to? That's amazing. That's amazing analysis. Thank you so much. It's supposed to be dotted. Absolutely, absolutely, absolutely. It's supposed to be dotted because there is no or equal to. So remember to do that part. Well done. Who's that? Who's that? What's your name? Well done, Misha. Well done. Absolutely great. Top stuff. I love it. Now let's see. Here we have x plus y equal to 2. We go to 240. This is where we are cutting it, but we are sketching the graph of y is equal to negative x. I said there's the graph of y equal to x, which you must know. Then you must know the graph of y equal to negative x. Y equal to negative x just follows the corners. Just go through every single corner from the point you started with. Go through every corner. So I'm going to be going through corners. And let me see if there's an or equal to. Yes, there is. So we are going to go through the corners nicely. So you go through the corners as a solid line. So it's going to be, let's just draw a solid line which goes through corners. But it must be going down because y is negative x. So it should be going down like what I'm doing right now. There we go. This is going to be the line. If you write it as x plus y, you can still do it. X plus y is equal to 240. Now we need 2x plus 3y is less than, which is y is equal to negative 2 over 3x. Plus 150, so you go to 150. It's starting here. Then it goes down. So all I want to know is another thing. 150 is equal to negative 2 over 3x. Then we take the negative 2 over 3x to the other side. Okay? We take it like that. It will go to divide. So it's negative 150 divided by negative 2 over 3 is equal to x. We want to see the value. Now what happens here? You say negative and negative cancel. Then 150 divided by 3 over 3. That's 3 times 150 over 2. This is equal to x. Now this is going to be 450 divided by 2 is equal to x, which is now, what is it? 2 into 2, 1 into 4, that's 2. 2 into 5, that's 2, remaining 1 into 10, that's 5. So it'll be 225 is equal to x. So it meets x at 225, which is halfway between 200 and 250. So now we just join the 2 points by a line. And we have the line. This one keeps going corner to corner like this. This is what happens. Now what do we do, class? We shade. We have these 4. We start shading unwanted regions. Let's first write the wanted regions. Are we all together? Are we all together here? Right. This is x less than. So the wanted region is to the left. This is y less than. So the wanted region is below. The wanted region. This is y less than. So the wanted region is below. This is y greater than. So the wanted region is above. Now we are going to shade the unwanted, which means we're going to shade to the right of this line. We're going to shade above this line. We're going to shade above this line. Then we are going to shade above. Oh, no, we're going to shade below. So now let's go for it. Remember, this is now, this was x plus y equal to 240. This is 2x plus 3y is equal to 450. Now let's go to the right of x equal to 180. This line, we go to the right and we shade. These are unwanted. Then the other unwanted is here above the line y equal to 90. You go up, y equal to 90. You go above it, you shade as well. There we go. We are going to shade everything that's above the line that is being talked about. All right. Then we want now above this other line, which is x plus y equal to 240. So we've already covered it. You can see that we cover it like this. It's above. We take the only region which we hadn't covered was this one. Now one more. We're going to cover below this other one, which is this one. We cover below it. So we're going to be covering below it. So it's going to be like this. Okay, you see, there's only one region which is not yet shaded, and you call it your R, then you're going to get 7 marks. 7 marks. 7 marks, 7 marks, 7 marks. Free 7 marks. Are we together? You're going to be able to do it, right? What are the steps? Change to equations, sketch the lines, shade all the unwanted region one by one, then you find a small region which is wanted. You can revisit that first question which we did and didn't finish, and you must be able to do it. Are we together? Students? That's how this region was found. Anyway, I feel like you have enough on these bounds. On these, what is it called? Inequalities. You've had enough, right? Okay, I'll give you some questions to do where you'll be dealing with this, and I'm just going to see how much you'll be able to do it. So, I've got 2 minds. Should I do physics? Should I do math? Should I do physics? Okay, let me just finish up with one more thing. And then tomorrow we are back to physics. I'll do one thing which is going to help us to finish the chapter tomorrow. So it's going to be a very heavy physics lesson. Make sure you're ready. I'll do a few questions as well that I've already organized them for you. I didn't want to give you too much assignment, too many questions for your assignment, but I've already done the questions on uses of electromagnetic waves. I'll combine it with the other thing we're doing tomorrow, then give you an assignment. For those who couldn't do bio, go to my Facebook page. Just go to Facebook and say Mr. Clarify, or go to YouTube and say Mr. Clarify. Sometimes I'm putting the videos there, so you can be able to watch from there. Are we together? Good. You can be able to watch if you go to YouTube, you say Mr. Clarify, then you go to live videos, not to videos. You go to my channel, you go to live videos, you'll be able to see the videos. Let me just finish with the last thing we are doing. So if there's anything which you haven't really mastered, you go back and rewatch this video, you'll be fine. The last thing which we want to master is bounds. Then you can all take a break. I'm going to explain bounds for just a few minutes, and then you can take a break. So there is a concept that I want everybody here to agree with me before we talk about bounds. Right. I want you all to agree with me here. Please. All of you. I want you all to agree with me that if you are going to have, let me start with 1 over 5. This is 1 over 5, right? If I now increase it, then I say 2 over 5. 1 over 5, if I change it to a decimal, it's 0.2. 2 over 5, if I change it to a decimal, it's 0.4. Are we together? 4 over 5, if I change it, it's going to be 0.8. Let's say 3 over 5 is going to be 0.6. What I want you to see is, are we changing the 5? Students, are we changing the 5? In the 3 fractions, did we change the denominator? No, we didn't. What did we do to the numerator? What is the numerator doing? Is it increasing or is decreasing? From 1 to 2 to 3. What is the numerator doing? The numbers on top. What? We are increasing the numerator. We are making it bigger and bigger. What does that do to our answer? Is our answers, what is happening to our answers? Are they getting bigger or smaller? What, they're getting bigger, right? 0.2, 0.4, 0.6. The answers are getting bigger. So listen, don't let me down here. If you have anything that is a fraction and you want a big answer, you make the numerator big. The top is good. If you want your answer to be big, make the top big. Let's do another one. What is 4 over 4? Hello? What is 4 over 4? 1. What is 4 over 2? 2. What is 4 over 1? 4. What am I doing to the numerator, to the denominator here? I'm decreasing it, right? From 4 to 2 to 1. I'm decreasing. I'm making it smaller. What is happening to the answer? We have to agree here. What is happening to the answer here? The answer is increasing. So, can everybody in this class, as long as you are in this class, you are not leaving until you agree with me that to make an answer small, you make the denominator big. If you have a big denominator, your answer will be small, my friend. The denominator is an enemy. If you want an answer to be big, you make the top big and you make the bottom small. So let's just say it like this. If I have A over B, how do I get a big answer? How do I get a big solution? What should I do to A? I'll make it big. The bigger it is, the bigger the answer. And what do I do to B? I'll make it small. Then I'll get a big solution. Right? If I want a small solution on a fraction, if I want a very small solution, very low, then I'll have, if I have A over B, I will make this small. Then I'll make this big. So basically, let's say it like this. What you do to the top is the answer you are gonna get. But make sure you do the opposite to the bottom. So if you want a big answer, make sure the top you make it big. If you want a small answer, make sure you make the top small. You get a small answer, but try to make the bottom be vice versa so that it's better. Are we together? So this is the secret, the first secret when you are dealing with bounds. If you are dividing, listen, if you are dividing, you must know this. If you are multiplying, if you want a small solution, it's different from divide, man. When you want a small solution and you are multiplying, make these things small. So make it small, you get a small solution. If you want a large or big solution, then you're going to make A and B, both of them, to be large. Then you're going to have a large solution. Are we together? Students, are we together? All right. Everybody, are we together? Good. So bounds has two things that if my class can only understand, then this chapter will never be hard again for them. When you're walking into bounds, you must know that there are two things involved. Number one is getting bounds when you have measured things. What are bounds, sir? Bounds are, we are trying to see, let's say we are trying to make our answer as correct as possible. But we know that as human beings, when you measure things, you will never be perfect. So what we are doing, we are helping you. You have done a measurement. You have measured. But what we know is that you are a person. You are a normal person. You're not going to be perfect. So you're going to make an error. But bounds are going to protect you. So after every measurement, you must find bounds. So, sir, bounds are going to be after every measurement? Yes. This thing called bounds is dangerous. It comes in every exam. Listen, don't let me down. Why would you let me down? What will be your reason? Am I not telling you everything? On inequalities, didn't I tell you to make them lines? Didn't I tell you to draw the lines of equations? After drawing the lines of equations, didn't I now tell you how to see the regions which are wanted? And then didn't I tell you how to now see the regions which are unwanted? And didn't I tell you to now shade all the regions which are unwanted? Then you remain with the small. Didn't I tell you? Am I not telling you bounds now? So why would you not get it correct? Why would you let me down? Am I not telling you everything? Listen now, because you're not going to let me down. Bounds, first I told you what they are for, because I know what they are for. I know that you meet them when you do A-level physics. But I don't want to tell you too much. But I know that for you to love the topic, you need to know why it's even necessary. Because I had those questions at your age. Are mathematicians mad? People who do physics, are they mad? Why do they do those meaningless things? These things are not meaningless. When you are designing an aeroplane, listen, when you're designing an aeroplane, you have the wheels, you have the wings, you have the body, you have the windows, you have the door, you have the everything. Those parts are not made together. They make the door, then they make the wings, then they make the seats, then they make the windows, then they make the fan, and they make them separately. But they want these things to fit perfectly when they bring them together. So they know that because these things are being measured by a person, you are never perfect. Don't lie to us. When you measure with a ruler or with a mass scale or with something, you are going to be imperfect. You are going to see to write the answer which is as good as what you think. But that's not the perfect one. We know that. So listen, bounds protect you. You're going to get deeper with this subject. But now, what must you know for IGCSE? Listen, for IGCSE, you should know that when you do bounds, there are 2 steps. Listen closely, please. When you do bounds, there are 2 steps involved. You know, don't let me down. I'm telling you everything. I'm giving you the best chance. You deserve a chance to pass. And the way you get a chance is if we tell you everything. So listen now that there are 2 steps. The first step is to find the bounds themselves after you have measured. Hey, bounds come from the fact that anytime you measure, you are going to make a mistake. So the first step I want everyone to do, so that I don't lose my mind, so that I am not disappointed, so that I am not going to see things that will make me collapse. The first step I want everybody to do is find bounds from measurements. Please, my students, bounds are from measurements. Don't you let me down. Hey, you're going to cost us. And we can't afford to have you cost us. Find the bounds from the measurements, because measurements are not perfect. So find the bounds. Then, second step, find bounds from calculation. The second step is find the bounds from a calculation. Cambridge is going to try to trick you. They are going to ask bounds from a calculation. Don't say I didn't tell you. I'm telling you right now. Cambridge will try to trick you. It will ask you to find bounds from a calculation so that you get stuck. But you have been told by me that that is the second step. You can never do it as the first step. Ignore their question. Go to the information, and the first thing I want all of you to do for me, so that I don't collapse, is find me bounds from measurements. Let's go to a question so that you see. We are going to find bounds from measurements. We have a formula for that one, okay? I'm going to give you using a formula. Then we will find bounds from calculations using this idea which we did here. To say, if we are dividing, this is now the second step. How we will then find bounds from a calculation. We will say, if you are dividing and you want an answer which is upper bound, which means the bigger bounds, because bounds have 2 of them. They have the bigger one, which is the upper one, upper bound. Then they have the smaller one, which is the lower bound. Okay? Are you listening? Bounds have upper and lower. If the question wants you to then find bound from a calculation, you don't use abracadabra. You use this in step 2. The fact that if the question asks for upper bound from a calculation which was dividing, upper bound means the bigger value. So the question wants the bigger value from a calculation which was dividing. You will use the upper bound of the top because you want a big answer, so you make the top big. And you will now take lower bound for the denominator because you make the top small. Lower bound means small. Let's go to a calculation. You are not going to cross it up. No. I know that your mind is fighting you right now because it's hearing a lot of things. But we are going to fight that mind of yours and we are going to convince it. That's the hardest job, to convince your mind to accept this. Look here. Okay? Let me start with an easier one. Look here, friends. You are not letting me down. No. That's not happening. Nina walks, then you are told speed. She walks for exactly 2 hours. Then they said, find lower bound for distance. Right. This is bounds. Now, let's go to the information we have been given. What have we been given? Average speed. And what? Time, 2 hours. Have we been given distance? Students, have we been given distance? No. So it's a calculation, right? But do we start by looking for bound for distance? No. It's illegal. Good. We need to find... No. We need to find the bounds for the things that we have been given. So let's start by average speed. We want the upper bound for average speed. So you can first try to say average speed is equal to 5 kilometers per hour. Now, what we want to do, we want to find the upper bound for average speed, even its lower bound. Upper bound for average speed, even its lower bound. Now, how do we find bounds? This one was measured. That's why you're seeing it saying correct to the nearest. So this one is easy. We find the bounds easily. Really? Yes. For things that are measured? Yes. How do you find the bounds, sir? You look at correct to the nearest. Whatever is correct to the nearest, that's where you take. So for us to find the upper bounds and the lower bounds, first we look at what is it to the nearest. It is to the nearest kilometer per hour, which means it's to the nearest 1 kilometer per hour. We take that 1 kilometer per hour, we divide it by 2, you get 0.5 kilometers per hour. So it's important that the first thing you do, you take the nearest, you divide it by 2. Then now you can find upper bound and lower bound. So for a measurement, you take to the nearest, you divide it by 2 to get your special value. This special value is the one which will now give us upper bound and lower bound. You take to the nearest, here they say to the nearest centimeter or to the nearest dollar, whatever, it will be meaning 1. So if they say to the nearest kilometer per hour, they mean 1 kilometer per hour. So you divide it by 2, you get 0.5 kilometers per hour. Now you can say the upper bound for average speed is going to be equal to 5 kilometers per hour plus 0.5 kilometers per hour, which is going to be 5.5 kilometers per hour. Then the lower bound for average speed is going to be equal to, you start with the value 5 kilometers per hour, then you subtract minus the answer you would have gotten, 0.5 kilometers per hour, then you find 4.5 kilometers per hour. This is going to be the lower bound for speed. So did we try to find bound for distance? No. What did we do? We ignored it. Why did we ignore it? Because we know that it was not given in the data. It's a calculation one. The only time we will get that one for calculation is if we have the one for measurements. So here we have the one for speed. Do we now have the one for time? Because we also need for this other one, which is time. Do we need it? No. For time, we've been told that it's exactly 2 hours. Okay? Hello? Okay. Yeah, we've been told that time is exactly 2. Now they say work out the lower bound for distance. Let's now say we now want the stuff for distance. So first of all, we need to put the formula. What is distance? We know that the formula said speed, then time, then distance. This is a triangle. Okay? You put a box at the bottom, then you put a triangle at the top. And it's like this. Speed, time, distance. Now what we're going to do, we'll say, how do we get distance? We get it by saying speed times time. So distance is equal to speed times time. Now they want lower bound for distance. What is lower bound? This is the stubborn part. So listen now. We are now doing bounds of a calculation. Bounds of for a calculation, I said you use these ideas. That don't change. Lihagwa. If they want a small, if you are multiplying, you will be checking in your formula that you now have. Are you multiplying? Or are you dividing? Or what? Here we are multiplying. If you are multiplying and you want a small solution, lower bound, then you need to make A be small, B be small. So you need lower bound for this measurement, then lower bound for this other measurement. Are we together? Lower bound for both measurements. Are we together? If we get lower bounds for both the measurements, then we will have lower bound for the answer if it's a multiplication. Okay? So let's go back. They want what? They want lower bound for distance, which is a multiplication. So we will now say, hey, distance lower bound, the lower bound for distance will be equal to speed, its lower bound, times time, its lower bound. But for time, we can't put lower bound because it was an exact thing. So it will be the lower bound for speed. What is the lower bound for average speed? 4.5. So we are going to use 4.5 kilometers per hour. Then we multiply by time. Time was a bit too exact, so it was 2 hours. So we'll multiply by 2 hours and we'll get 9 kilometers. This is the lower bound for distance, 9 kilometers. Are we together? Don't change the steps. Let's do another one. You have been given the formula. Can we all see? Okay, can you hear me? Okay, can you see my screen nicely? I said, how do you lose marks? If you throw away everything that was said, that's the only way to lose it. Because you people know clearly what to do here. All of you know. Misha, you know clearly what. You know that this is a setup. This is a trap. A clear trap which is in daylight. They are asking you for a bound from something that they didn't give you. From something that you calculate. But it's impossible. I've told you. First, before you even talk about bounds of I, you need to know the bounds of V and of R. Because these are the measured quantities. the measured things, we can easily find their bounds. So let's do it. Let's find the bounds for V. How do we find bounds for V who is measured? You look at to the nearest. You can't forget this one. Look at what is to the nearest. It's to the nearest 10. Take that 10, divide him by 2. So you say 10 divided by 2. You will get 5. This is the special value which we will use to find bounds. So now you're going to say V upper bound. The upper bound for V is going to be 50 plus 5. You add and you get 55. This is the upper bound for V. Then the lower bound for V will be equal to 50 minus 5, which will be 45. Then we now work with R. We want to find its bounds. They said correct to the nearest integer. Look at what is correct to the nearest integer. What is the smallest integer? That's 1. You divide it by 2, you get 0.5. They are not fooling anyone. Okay? The smallest integer is 1 divided by 2. You look at to the nearest, you take that thing, you divide it by 2. Then you add to get upper bound and subtract to get lower bound. Where is the problem there? The problem will come if these steps are not followed and you expect to get to the answer. How can you expect to get to the answer when you're not following steps? Do you think this is abracadabra? So now you're going to say R upper bound will be 13 plus 0.5, which will be 13.5. R lower bound is going to be equal to 13 minus 0.5, which is 12.5. Now we are at I. We now want the upper bound of I. So you're going to write in the formula I upper bound. In the formula. First you can put the formula maybe. I is V over R. Then now you say I upper bound. I want the upper bound of I. Now you can talk about it. Because you have those guys. Now, how do you then get upper bound of a calculation? I explained to you what you want here. You want the bigger one. So you make the top the bigger one. It means you find upper bound of the top. Then you do opposite to the bottom. You find lower bound of the bottom. Concentrate, concentrate, concentrate. Anything which is at the top, we find its upper bound. If we want the answer to be upper bound, then anything at the bottom, we find its lower bound. So that's what we're going to do. Go and take upper bound of V. It should be there. Here, it's 55. Then divide by the lower bound of R, which is here, which is 12.5. Then tell me what you get. That's the answer. It's what? 4.4. So your answer is 4.4. Somebody will not do this and will put themselves in a bad position. Am I to blame? No, I'm not to blame, my friend. I have given you the steps. Steps give you answers. No steps is equal to no answers. Steps is equal to all answers. You get any answer, any question, you will go there with your hands in your pockets. Why are you being so proud? It's because I know that I know. How do you know? What if the exam surprises you? It can't. How do you know? I follow steps. So I am safe. That's a message. Let's go to one more question. Can you see this? Students? Let's do this. Hey, 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 hey. What? I'm not interested in reading this line. This line gives me a headache right now. I don't even want to read it. I want to start with what I've been given here. Grocer buys 620 kgs of onions, correct to the nearest 20 kg. So I'm going to find the bounds for this guy. I'm going to say 20 kgs divided by 2. This gives me 10 kgs. So I'm going to say onions bought, the upper bound will be equal to the upper bound of the onions that were bought will be equal to 620 kgs plus 10 kgs. This special value, if you don't start by dividing the to the nearest by 2, if you don't divide this by 2, then I don't know anymore. You gotta divide it by 2, then add to get upper bound and subtract to get lower. So this will be 630 kgs. Then you can say the onions, the mass, it's actually a mass, but anyway, onions bought, the mass, the lower bound will be equal to 620 kgs minus 10 kgs, which will be equal to 610 kgs. This is the lower bound for onions bought. Then we come into bags. So I would love to say this is the mass, the total mass. I would love to call it total mass because kg is a mass. So I can say total mass of onions, the upper bound. Let's just call it, man, total mass, total mass. Okay. Then here, mass of bag. We now want to find the upper bound and whatever for the mass of the bags because it is putting it into 5 kg bags. Oh, the number of bags. All right. So let's see here. We are going to find mass of a bag, of each bag. First, we look at to the nearest. It's to the nearest 1 kg. So we say 1 kg divided by 2 is 0.5 kgs. They could have just said kg without 1. To the nearest kg, it means 1 kg. Now you're going to say mass of bag, the upper bound, will be equal to the measured value, 5 kgs, plus this special answer, 0.5 kgs, which will be 5.5 kgs. Then the mass of each bag of bag, the lower bound, will be equal to 5 kgs minus 0.5 kgs, which is going to be 4.5 kgs. Then now you will say number of bags. First you need the formula. Number of bags. The n of bags, which means the number of bags, is going to be equal to total mass divided by the mass of each bag. Now, what we want is we want the upper bound for the number of bags. So you need to be knowing how to find at least this. This is where it's going to be hard. Make sure you make the formula nicely. Now you want upper bound for that. Okay. So we'll say number of bags. Even if you put hashtag or whatever, it doesn't matter. Its upper bound will be equal to total mass. What about mass? Do we find the lower bound or the upper bound? For this one on the top, we find the upper bound because we want upper bound for answer. So this will be total mass, the upper bound, divided by mass of bag, the lower bound, okay? Because it's the denominator. You make it small. You want the answer to be big. You make the top big, the denominator small. Don't argue. What you want here here, you put it here, and you do opposite in the denominator. So don't ever change that. What is the total mass? Its upper bound, 630 kgs. So it'll be 630 kgs divided by, what's the lower bound for the mass of each bag? 4.5 kgs. And how many bags do you get? 140 bags. What a super good person, getting all marks because you follow all steps. I don't want to be disappointed. I'm hoping that you will not disappoint me. I hope. Thank you. I'll give you questions to do, and we'll see how good you do them. My questions are to be done, and my assignment is to be submitted. I'll check everybody. I hope everyone in my class has submitted the assignments so far. For all the subjects, including the bio one I gave you in the afternoon. I'll be going through it tomorrow. It's a Sunday, so yeah, that's good. And tonight as well, when you're asleep. And we go through new things tomorrow. I'll do the last part of inheritance and questions, and the last part of waves and questions. Monday is a new day. Variation and selection. We are coming for you, Mr. Man. We are coming for you, variation and selection. And I'll give you the video link to the solutions for all the assignments because I record after marking. So next up, variation and selection. The order of lessons now everybody knows. I teach you, I give you assignments, I mark, then I record a video of the solutions. So this is the order, and it shall not be broken. Ladies and gentlemen, boys and girls, thank you for attending. This is how it is. You attend every day. You don't skip a day. We move on tomorrow. Goodbye. Good night, my students. Night.